Hello, welcome to everyone in this video. This is our lecture number 2 for the problem solution of electronics. There is different playlist for the theoretical part of electronics for uh, BSc honors 4th semester of University of Calcutta. This syllabus actually followed. In the different playlist there is theoretical part are covered, and in this series we will discuss the problem solution asked in the different books, or you can say previous year solution. Okay, in this video want to discuss about the previous year solution of University of Calcutta. Okay, so before that you must watch the theoretical part so that you can understand the theory, and then you continue this series, this video. This will be helpful. At first you need see the question and pause the video and try to solve this question. After that you continue this video to watch this solution. Okay, at first you, when the question display, you pause this question and try to yourself, and then verify with the answer which are discussed in this video. If there is any problem, you must comment in the comment box. Let's start with first question, which asked in University of Calcutta 2021. The question asks that determine the Thevenin's equivalent circuit between AB. So these are this point A and B. You need to find out the Thevenin equivalent circuit across this AB, and then find the current for load resistance when 10 ohm. So first we need to find out this Thevenin equivalent circuit. For Thevenin equivalent circuit, you need to two things. First one is the Thevenin voltage. Second one is the Thevenin resistance. How we will find out the Thevenin voltage? Thevenin voltage will be calculated by omitting this roll resistance. The voltage across this AB is the Thevenin voltage. Since there is no current, so there is no voltage difference across 5 ohm. So the voltage difference across 20 ohm is the Thevenin voltage. So you need to find out this voltage across 20 ohm. For that, you can consider the loop current. In this loop current is I1, loop current is I2, loop current is I3. Now, if you write down this equation of this, you can see that is 20 ohm into I1, that is 20 ohm into I2 minus I3, and this is 5. So 20 into I1, this is 20 into, clear, 20 into I1. We take this loop 2 and 1 and 2, this loop, because if you take this loop the current is problematic. That's why we take this is the loop where the resistance and voltage actually happening. So within this resistance flow up I1, so 20 I1, within this resistance 20 I2 minus I3, I2 in that direction, I3 in that direction, opposite direction. Okay, and the voltage source supply this in the same direction, positive is same direction, that's why 5. So if you rearranging them, you will be get this relation, and you can see here this I1 along that and I2 along that. So I2 minus I1 must be 1, I2 minus I1 must be 1. So I2 minus I1 equals to 1. So I2 is nothing but 1 plus I1. So if you put this value of I1 here, you will be get this relation between I2 and I3. Take this loop number 3. You can see this 10 and 20, that is 30 I3 plus 20 I3 minus I2. I3 minus I2 equals to 0. If you rearranging them, I will be get this relation. To omitting this I2, you need to find this current I3. That's why we omit the I2. So just multiply with 4, you will be get this. If you added this 1 and 2 equation, this 8 I2 is cancel out, you will be get this 16 I3. So I3 equals to 5 by 16. 5 by 16 is the current through this 20 ohm resistance. So the voltage across this 20 ohm is nothing but current into resistance, which is 25 by 4 volt. So the Thevenin voltage of this circuit is 25 by 4 volt. I think clear. If there is any doubt, you must comment in the comment box. Okay. So this is the method by which we can find out this Thevenin voltage across this load, that is the point A and B. There is another method you can get the same Thevenin's voltage. If you wants to find out this method, uh, if you understand this method, no problem. If there is any doubt, there is another approach to solve this problem also, so try to understand this one. Okay, same circuit, we take this one. You need to know about the Thevenin theorem and Norton theorem, then you will be apply this method. Okay, you know, in Thevenin theorem, this Thevenin voltage with the Thevenin resistance in the series, and Norton, there is a parallel connect, Norton current parallel with the Norton resistance, right? So these two are equivalent. You know, these two are equivalent. Norton and Thevenins are equivalent. Where IN, Norton current, is nothing but no, Thevenin voltage by resistance, and Thevenin voltage, Thevenin resistance and Norton resistance are the same. So these two are equivalent. Then you can see here this portion. You can see here this portion. You can see here this portion is nothing but the, like that, Norton. So you can replace this one by a, you just put this point AB. So this is the AB. So these are parallel. So AB can be replaced as this resistance with the voltage. So if you understand these two are equivalent, and you can see this parallel combination of current source and resistance, you can replace these things by this voltage source and resistance. So IN is like that. So VT is nothing but IN into RT. So here the IN is nothing but the current, which is 1, and RT is 20, that is 20 volt. So this portion can be replaced by this one. This portion can be replaced by this one. Okay, by this one. Clear? Just draw a lighter. This one. Clear? This is the Norton actually converted into Thevenin. If you understand these things, you can easily now find out this KVL using this loop. Two loop used in this loop I1, and this is loop current I2. So for that equation will be 20 I1 and this 20 I1 minus I2, and the voltage will be 5 and this is minus 20. Okay, so you will get this relation. And for loop 2, the equation will be 10 plus 20, 30 I2, and this 20 I2 minus I1, 20 I2 minus I1, 10 I2, 20 I2 equals to this 20 voltage source 20. So you will be get this relation, and just rearranging them and solving with this equation, you can easily find out this value of I2, which is 5 by 6, which is similar to previous one, 5 by 16. Sorry, 5 by 16. So finally you will get this Thevenin voltage will be 25 by 4. So any method can be used if you understand this one. Okay, no problem. If you understand this one, no problem. You must follow any one method to get this voltage across that one. Now we need to find out the Thevenin resistance. How will we get Thevenin resistance? The voltage source are shorted, or it is replaced by its internal resistance. When we apply this Thevenin resistance, you need to replace this voltage source with its internal resistance, and the amperes on the current source are be opened. Current source will be open. So now the circuit will be like that. You need to find out this resistance across AB. So you can see here this 5 ohm, then this combination and 20 is parallel, and these two are parallel. So 20 parallel, and then 10 series, 20 parallel, then series. Total is parallel with 20. Total is parallel with 20, and this total is series with 5. This total series with 5. I think clear. This circuit is redraw in the different manner. This is point A. If you follow up this point A 5 ohm, then divided two part, this one and that one. That one is 20, reach the point B, and that one is 10, reach point some point. Write down this point as a C. If you write down this point as a C, so sorry, if you just draw, this is C, so this is C. After C there is 20, you will be get B. After D, this point is D, this point is D, these two are combined with B. Okay, so now you can just 20 parallel, that means 10. So 10 10 series, that is 20, 20 20 parallel, again 10 10 5 series 15. So Thevenin resistance is 15. Clear? And Thevenin equivalent circuit will be, this is the Thevenin voltage and this is the Thevenin resistance. So Thevenin voltage, Thevenin resistance, and the load current. The question says when the load current is 10 ohm. So if you put this load current is 10 ohm, the current of the circuit, that is the load current will be the IL. So IL is nothing but total voltage by total resistance. Total voltage is VT, total resistance is RT plus RL, RT plus RL. Okay. So put this value, will be get 0.25 ampere. So this is the current flow within this loop using this Norton theorem. I think clear. If there is any doubt, you must comment in the comment box. Go to the next one. Next question was asked in CU 2017, which says calculate the voltage drop and power dissipated across this RL in which circuit below using Thevenin theorem. You can use this Thevenin theorem. You need to find out this voltage drop across RL and the power dissipation, and find the value of RL for which power distribution across RL will be maximum. So for Thevenin theorem, you need to find out this Thevenin voltage across this one and Thevenin resistance. So for Thevenin voltage, you can see these two are parallel, and you know parallel with 0 is multiplication by summation. So if you multiply 0 into 100, you will be get 0. So this is nothing but a short circuit. Okay. So this is 10, this is 10, and this is 10, and these two 20 20 parallel will be also 10. Now the voltage across this point will be equals to that one, because no current flow through this resistor because this is disconnected. So the voltage across AB, if you write down this as AB, it must be equal to the voltage across this resistance. So this is nothing but the current into this resistance. What will be the value of current? Current is nothing but voltage by total resistance. That is 10 plus 10. Okay. So the VT is nothing but this current into 10, will be get 5 by 2, 2.5 ampere. And the Thevenin resistance, this you can see this is 2 parallel combined series with 10. So 10 plus 10 parallel 10. So 10 parallel 10 is 5. So 5 plus 10 15. So the equivalent circuit will be like that, where Vt equals to 5 by 2 and Rt Thevenin resistance equals to 15 and Rl. You know from the maximum power transfer theorem, the maximum power will be delivered with the load maximum when the internal resistance is the equal to the external resistance, that is the load resistance. When the load resistance is equal to the internal resistance, then the maximum power will be transferred. So you just equal to that is the RL is nothing but equals to RT, then the power will be maximum. So this is the condition, the power will be maximum when these two are equal. So the voltage across this one is nothing but current resistance. Current is voltage by total resistance. So this will be the value of voltage, and this is the power I square R. So if you just derivative with respect to RL, I will be get this one. Using maximum power transfer theorem, directly write down this one, that is the external resistance, that is a load resistance, must be equal to the internal resistance, is the condition for the maximum power transfer from source to load. Clear? So directly you can write down this. Otherwise you can derivative this part, first derivative, second derivative, from where you can also find out the maximum. That is actually the maximum power transfer theorem. Okay, next one. Find the value of RL for such that maximum power is delivered to it, and also the value of maximum power. So maximum power is delivered to it means the load resistance will be equal to the internal resistance, which is the Thevenin resistance or Norton resistance. So maximum power transfer when these are the two equal, that is the maximum. So so Thevenin circuit will be like that. For that, the is replaced by its internal resistance, that is 0. So this will be 2 and these two are parallel. So 2 plus 3 parallel 3 plus 1. So you will calculating, which is 4.5. So when RL equals to 4.5, maximum power transfer. If you want to find out the maximum power, you need to know about the Thevenin voltage. What is the Thevenin voltage across this point? So there is no current flow to this one. This current flow out to this loop. So I is nothing but 18 by 3 plus 3, which is 3. So 3 into 3 is the voltage, that is the Thevenin voltage. So Thevenin equivalent circuit 9 volt, and this is the 4.5, and these two are equal for maximum power transfer. So P max is nothing but the I max by I square R. I is nothing but current voltage by total resistance, and these two are equal. So finally you get this one. Clear? Next one. Next is the says state Thevenin theorem. You can state this one easily, no problem. From theoretical part, you can cover up this part. Using Thevenin theorem, find out the current through this 12 ohm. You need to find out the current through this 12 ohm according to Thevenin theorem or using the Thevenin theorem. Okay. So, for use Thevenin theorem, you need to find out the Thevenin voltage and the Thevenin current. What will be the Thevenin voltage when this will be omitted? This is open, and measure using the multimeter. You will be get this voltage at these two terminal. So this circuit is redraw is like here. You can see this is 24 36, and this is 36 24, and this AB, this resistance is eliminated, omitted. So this 2 point AB. So you need to find out this voltage difference across AB. So what will be the voltage difference? This is nothing but the voltage difference across 36 and 24. 36 into this current and 24 into this current is the difference. What will be the value of current? Current is nothing but total voltage difference is 5. So this 5 by total resistance is the current through that side, and this side current I2 is nothing but 5 by addition of these two. So just put this value. 5 is the voltage, and total resistance is 36 plus 24, and here also 36 plus 24, which is 60. So just calculating, you will be get 1 volt. So the Thevenin voltage is 1 volt. And Thevenin resistance, for Thevenin resistance you can see here this will be sorted. When this is sorted, you can see these are sorted, so these are the parallel and these also parallel. So these two parallel are connected in series. So these thing two are equal, so that's why 2 into 24 into 36 by 24 plus 36, which is 28.8. So this is the Thevenin resistance. So the equivalent circuit will be like that. Thevenin voltage is 1 volt, Thevenin resistance is 28.8 ohm, and the load resistance will be 12 ohm. So the load current is nothing but this voltage by total resistance, voltage by total resistance. So this is the load current. Clear? So we can find out easily this load current using Thevenin theorem. Next question. Find out Thevenin and Norton equivalent circuit between the point A and B. This is through point you need to find out the Thevenin equivalent circuit as well as for Norton equivalent circuit. For Thevenin equivalent circuit, you need to know about Thevenin voltage and the Thevenin current. Thevenin resistance. What is Thevenin voltage? The Thevenin voltage is nothing but the voltage across this voltage across these two terminal. Voltage across these two terminal is the Thevenin voltage. Voltage across this one. So how will we find out this voltage? So you can see there is two loop. This is the loop and this is another loop. So you will take this loop current I1, this loop current I2. So use this KVL in this loop. You can see that is the 10 is equals to 5 10 1 5 10 1 I1, and in this 5 current is I1 minus I2. So if you rearranging them, you will be get this equation. And for loop 2, this 5 into I2 minus I1 plus this 1 into I2 equals to minus 10, you will get this two relation. If you solve these two relation, you will be get this value of I1 and I2. Just check this calculation. You can do this yourself, very no problem. And after getting this string, you will be get this Vt. Vt is nothing but this voltage difference, which is 10, and the voltage drop due to 1 ohm and this 10 ohm. So for 1 ohm this will be the minus, and 10 ohm this will be for the plus positive. So you'll be get the final value 9.5 ohm. Okay. So this is the Thevenin voltage. What is the Thevenin resistance? During Thevenin resistance, this voltage source replaced by its internal resistance. So if you just parallel these two things, it will be 5 by 6, and these are series of 65 by 6, and these two parallel again, and this series. So finally we get This is the Thevenin resistance. So this is will be the Thevenin equivalent circuit, Thevenin voltage, Thevenin resistance. So what will be the value of this one? Okay, this is the Thevenin equivalent circuit. Now if you wants to Norton current is nothing but Thevenin voltage by Thevenin resistance, and you know Thevenin resistance and Norton resistance are equal. So this is the Norton current and this is the Norton resistance, and the equivalent circuit of Norton equivalent circuit will be like that. This is the current source and with parallel with the Norton resistance. Next question. Using Thevenin theorem, find the current through 6 ohm connector. I think you understand this question which already discussed previously just before. With the defined value, process will be the same. You just check the answer. I think you understand. So just check this answer. This is the Thevenin resistance and this is the Thevenin voltage, and the following current will be like that. Okay, just check this answer. The process will be same as discussed. Next question, draw the Thevenin and Norton equivalent circuit of the following. Find VTH and RTH between A and B. You need to find out the VTH and RTH between A and B. So for Thevenin voltage, you will be get this one. The current will be nothing but this voltage by total resistance. So the current will be this. So the voltage across this will be 3 volts. So Thevenin voltage is 3 volt. For Thevenin resistance, this will be sorted up. So 2, 3 are parallel series with 4. You will be get 5.2 ohm. So this is the this is the Thevenin resistance. So the Thevenin equivalent circuit will be like that: Thevenin voltage, Thevenin resistance, and the Norton current will be like that. So Norton equivalent circuit will be like that. Same thing. Next, find the Norton equivalent circuit of this one. So finally, directly you can use the Norton equivalent circuit. That means you need to find out Norton current directly from the circuit. How? You just sorted this one. You just sorted this one. This 4 and 5. Sorry, 4 and 10 parallel, and this one. So finally, you can see that is 10. And when this is sorted up, you can see these two are parallel. So resistance parallel with short, that means this equivalent to 0, because 0 into 10 by 0 plus 10 multiplication by summation. So 0 into 10 by 0 plus 10 becomes 0. So this will be like 1. So finally we get this one. This is in. If you just take this I and this is in, so just use the KVL. That is 10 is nothing but 4i plus 4i minus in. You will get this result. For second loop, you can see this 8in and here this 4in minus I. So you will get this one. So if you just solving these two, you will get the value of in, that is the Norton current, 0.5 ampere. For Norton resistance, same things as the Thevenin resistance. The resistance when these voltage source are replaced by its internal resistance and current source is open. You can see here from that point there is divided in two parts. 10 is becomes to that one. If you just write down this name point, if you take this is A, this is B. So A is divided two parts. A is divided two part. 10 is becomes B directly. Another 8 is become, this point is suppose C. This point is C, and C and D are become connected with B. So C and from these 4 are connected. So these 4 and 4 are parallel. So 4 parallel means 2, and 2 and 8 is series. So this is 10. 10 10 parallel means 5. So Norton resistance is the 5 and the Norton current will be the 0.5. So here the Norton current is 0.5 ampere and the Norton resistance is the 5 ohm, and this load resistance given here 5 ohm also. So this, you can see this voltage across these two resistance must be equal. So the resistance into current to this IL, if this is IL, this is IN minus IL, because total current supply here is IN. If the current from this load is IL, then the current flow from this Norton resistance must be IN minus IL, and these are in parallel, so the voltage must be same. So voltage across this RL is nothing but IL into RL, and the voltage across the Norton resistance is nothing but RL into IN minus RL. So if you just put this value of IN, you will be get the value IL, that is the load current. Clear? Next question. Here the same question, using Thevenin theorem, find out the current through this 2 kilo ohm. You need to find out the current through 2 kilo ohm using Thevenin theorem. For Thevenin theorem, you find out the Thevenin voltage and Thevenin resistance. How will we get the Thevenin voltage? Just eliminate this resistance. You will be get this voltage across this one. So you can see this 6 and 6 in parallel. So 6 and 6 parallel means 3. So this circuit will be reduced like that. So this I is nothing but the voltage by total resistance, and the voltage across this one, that is the Thevenin voltage, is nothing but current into 3I. So I is 10 by 9. So finally we get 10 by 3. For Thevenin resistance, this will be the equivalent circuit. So 3 parallel, and sorry, 3 series parallel with this 3 parallel, 3 plus 3, that is 6. So we get 2 kilo ohm. So this is the Thevenin equivalent circuit, Thevenin voltage, Thevenin resistance, and this load resistance also 2 kilo ohm. Load resistance also given 2 kilo ohm. So finally we will get this one. So the current flow to this resistance will be like that. So finally we will get this one. So this is the load current. And next question is the same type question already discussed previously. Just follow up this process and check the answer. Okay. So this will be the answer. So if there is any doubt, any question, you must comment in the comment box. You can send me this type of question in my WhatsApp number or the Telegram channel. This is all about me. You can connected with this Telegram channel. You can send me the question in this Telegram channel regarding this type of question. And this is my all these things, and this is my YouTube channel details. Go to this channel, you will get different fields related videos, some problem solution also. Like this session, if you learn something from this session, share this video to your friends, either he or she also get benefit from this video. Subscribe this channel if you need this channel. Those already subscribed, thanks for subscription. Press the bell icon to get notification of upcoming video. So take care, we'll meet in the next video as soon as possible. Thank you.